All right, welcome. The purpose of this video is to introduce the viewer to the ChemBox hardware and kind of how to find the schematics. I'm going to go over the design and kind of a high level so the viewer kind of understands what hardware is there. That way, when you're writing code, you can better understand how to make the system work. So the first thing we're going to look at is the folder structure in the Dropbox. So I'm going to go to the root of that folder, which I'm calling Rioux Chem Control Box, to kind of show you the structure of that folder as it is today, January 5th, 2014. But it may get bigger, but you'll get an idea, where things are at. So we're going to look at the circuit board and schematic for the Chem Control Box. So the first thing I want to point out to you is that all of the raw design files, if you want to look at the design, is under the folder raw design files. So first, we're actually going to take a look at that. Later on, we're going to look at what's in this order, build, and production data to order stuff. But right now, we'll click on raw design files. And we see three more folders. So the one we're concerned with is SCH, or schematic. This has all the hardware data for the circuit card, the main circuit card. The Mech folder is going to store any mechanical related stuff. For example, the front panel design through Front Panel Express. We're going to talk about that in a little while. There is no data in here as of yet, but that's where it's going to go. And any source code, that'll be stored locally here. We're going to talk about in a minute, all the source code is actually going to be stored online through the Embed compiler system. We use a little microcontroller module for this design called the Embed, and it has a cool little compiler, but there is some LabVIEW example code we're going to look at in another video that'll be in that folder. So the next thing we're going to do is we're going to go into schematic. Now, you'll see a Rev A, Rev Alpha, Rev Beta. The current hardware as of built today is Rev A. Now, there was a couple little minor fixes I did in Rev B. You should be able to look at either one of these, and I'll point out what the difference is. I'm going to look at Rev B, and I'll show you kind of the difference, but from a user perspective, you won't even notice. So if we go in any one of these folders, I can see the layout of the files. So just for your reference, the actual package used for the schematics is Altium Designer. So Altium Designer, you do not need to own a copy to be able to look at, but if you go to altium.com, you can actually get an Altium Designer viewer license. It's a fairly expensive tool, but if you want to look at the raw schematic files, you can. I provide some PDF outputs, so you can kind of look through the PDFs just to kind of view it if you want to know. But if you ever want to really look at the raw design files, they do have a viewer, Altium Designer viewer. It's free, you'll be able to get a hold of. So that's what the files are. There is here, for example, here's the Chem Control Box project file that if you have the viewer, you can open. But one thing I want to point out is in the build package, that has some files that are built from the raw design files. The one you really want to keep in mind is this under schematics, and there is a folder for PDF for the schematics you can look through. I'm gonna get rid of this old. Oops, the old Rev A. There's a carryover. Oops, because I'm looking at it. Sorry, I just want to get rid of the old version because it's near the folder. So you could look at this PDF file of these schematics. The other thing that's going to be in here is the raw bill of materials and the Gerber files. Now, you don't actually, when you're ordering, if you're ordering more parts, you don't want to grab from here. I've got another place called, it's under order, build, production data. That's where you actually want to go. And we're going to look at that a little bit later. So under go Rev A, it doesn't really matter. Under schematics, you can go in here, open up a PDF file, and take a look at it. Now what I'm going to do to make things easier for me is I'm actually going to bring over Altium Designer, and I'm going to pan around the schematics because it's a little bit easier to pan around in, and kind of go through the different elements of the schematic. So the first, the schematic is made up of multiple pages, and at the top level there's a top level page called Chem Control Box. Now from a user kind of perspective, if you're writing code, this is really what you want to ever need if you want to get the actual data as far as how things are pinned out. And this shows like the top level connectors. Now in the signal names. Now the driver code that's going to be given to you will kind of make it such that you shouldn't ever actually need this schematic other than if you're trying to wire up things to the external connectors. And I actually summarized all of that in another spreadsheet file that we can take a look at later. But I'm just kind of showing you this just kind of for your own reference. So at the top level, you can look at connectors. So for example, here is the main power switch. I can see a fuse. I see connectors, the little miniature connectors for the thermocouples. We can see all of those. There is a connector, a big block that represents the connector for all of the 12 RJ45. And you can see how they're exactly pinned out. On the right-hand side, we can see all of the screw terminals for, the heater outputs and the solenoid outputs. I show the green connectors that are used for the fan connections. And lastly, there's some connectors for the LCD screen. So really, the only thing this top level is showing you is kind of overall flow. These boxes in the middle, what they represent are kind of instantiations of, they kind of represent at a block level the other schematic sheets. So there's one in the middle called UMCU for microcontroller. This shows all of the I/O coming out of the microcontroller page. There's one for the analog input output, the solenoid digital I/O, the heater I/O, one representing the power supply. And they're just kind of blocks that represent the instances of these other schematic sheets. Now, if you're ever curious, and we're just going to take a quick look at what's in these different blocks. The first one I want to hit is the main microcontroller. And the reason I want to show you this is for the software perspective, this is what you need to know. So at the center of this design that controls all of the relays is an Embed Microcontroller. Now, what is the Embed Microcontroller? So I'm just going to go to embed.org. So the Embed kind of initiative was started a while back by a company called ARM, who makes microcontroller cores, and another company called NXP, which makes microcontrollers. Well, they made a nice little board, and we can go into getting started here. Actually, let me go in the handbook. They make a handful of boards, and I'm trying to find the one that's actually that we have. We'll say getting hold of some hardware, embed platforms. The one we're using is the first one they ever made, which is the Embed LPC 1768. It's just a little module that the circuit board, the big Rioux control board, is designed just to socket this microcontroller, and they just provide a really nice kind of development board for this microcontroller. You can plug it in, and it has this USB interface that we can essentially drag and drop new application code into. So as you're developing code, it's really easy to load in code, and they provide an online compiler, meaning you write code right within a web browser. So this really simplified the design that we didn't have to design this microcontroller from scratch. So it's similar to that of, say, an Arduino. The big difference is it's a lot faster, it's a lot more powerful, and it has a lot more I/O. And pretty much all of the I/O on this Embed is used for the Rioux control box. So this is what, at the heart of the design from a programmer, you need to know about. So in the schematic, that's what this block is here, is this this Embed microcontroller. Then I just send out all of the I/O to all of the chips on the board that implement our different stuff. So the first schematic, sub-schematic we're going to look at that the microcontroller talks to is the temperature sensor inputs. Now the temperature sensors are K-type thermocouples, and they come into these K-type thermocouple chips, the MAX 31855. Now from the user perspective, once again, you don't need to know much about them other than there's a driver for them. I'm going to provide a different video I'm going to make is going to have the software, talk about the software, but I provide you a nice C function that'll be as simple as get temperature, and it does all the has all the low-level code to read temperature. But I just want to make sure you're aware that's what's providing the temperature input. On the page heater SSR, the main solid-state relay we're using is the S116SO2 SSR. This is an AC only solid-state relay. It can only switch AC power, and it's good for up to, say, 15 amps. Now they will get a little warm. There are heat sinks, and that's why there's fans in this hardware system. Is for it's for the heater, or I'm sorry, for these solid-state relays. Once again, from the software perspective, you're going to get a nice function called enable heater channel, and that's all you really need to know. But if you're curious about the hardware, that's the solid-state relay. For the solenoids, it's also very similar. It's just a different solid-state relay. It's just a lower power version. There's 12 of them. It's a PR3BMF51 series. These are good for, I think, half an amp. Once again, it's just for those 100 milliamp solenoid valves, and there's 12 channels of them. So you can kind of look through those connections. The analog I/O, this provides all of the A to D converters for the mass flow controller inputs and the general purpose analog inputs. All of the channels have a what's called a saline key input filter to kind of filter out high frequencies to smooth out the signal. And all the signals come in through these A to D converter chips. Now, you don't need to know a whole lot about these A to D converter chips. There is a driver within the source code I'm going to provide that does all the magic. You're just going to say read channel, and it's going to give you the data in volts. But I just wanted to point out the voltage. It's here. There are some D to A channels as well for the analog outputs for both the mass flow controller and the analog outputs. Once again, you're going to get a nice driver that does it all. You don't need to worry about the details of how the Embed talks to the D to A's and A to D's. It's just going to do it for you. That's what I've provided. So lastly, there's a schematic for the power supply. The power supply is some modules on the circuit board that take 120 volts AC in and give us plus and minus 15 for the mass flow controllers. And it also generates 5 and 3.3 volts for the Embed and the logic on the circuit board. The only thing to note, there is a relay that's under software control that will route power to the MFC mass flow controllers, jacks as needed. So that's kind of the schematic from a high level view. One thing I did want to point out is in the root directory, of where all the files are, there is a file called Chembox RJ45 pinouts, and it's just a nice Excel sheet that has a kind of like a quick view, a quick cheat sheet of all the pinouts if you don't want to go to the schematic. So what these boxes up here show is if you're looking at the RJ45s from the front of the box, what each of the jacks are for example, mass flow controller channel 0, and I show the pinout. Now the only thing you need to know about if you're plugging in, if you're making your own cable set, is if that cable is wired for T568A, which is more, it's a newer, but it's more common in Europe. Most US cables are T568B. So it shows you the pin and then the color, all right? And then you can map that to the signals you need. So it's a quick cheat sheet, and you can use this kind of directly. Now, before I go, I just want to show you the PCB design. Now, you don't have to really get into this a whole lot, but Altium Designer gives me a quick 3D viewer that shows me the 3D view, and I just wanted to step you through the different components. So on the front side of the circuit board, and this is what's going to pop out of the front side of the rack mount enclosure. I'll go to the front, and we'll kind of look at it. We can see there is a connector with all those RJ45s. That's what maps to that spreadsheet I just mentioned. There is the Embed Microcontroller. There's a USB port. The top one is going to be used for programming. This device is the LCD that you'll be able to program. There's nice functions. There are 12 thermocouple inputs for the Omega thermocouple mini connectors. These two black boxes on the front are actually for 2 fans. The idea of the fans, once they're turned on, the front panel is going to have some like an opening for these fans to suck air in. The air is going to come in and hit these solid state relays. Now, it's not pictured on this 3D view, but there are heat sinks mounted to these solid state relays. And then there's going to be an opening in the back for all of these wire terminals, which you attach your 120 volt outputs. Well, the air is going to move through a gap that's exposed in the back of the case where these wire terminals pop out. So that's the idea, is air movement will just kind of come through from the front of the box to the back of the box. Now, on the back of the box, the idea is the back plate to the rack mount enclosure will have an opening that will allow these screw terminals to come out so you can attach your 120 volts AC outputs. You can see the 120 volts AC input, a switch, and a fuse. So that's pretty much the board design. The only other note is that the fans have discrete wires. You're going to be able to wire the fans into some screw terminals, on the main board. Everything else on this board are just the raw components you need to populate the board. So that's as you're building it up, you'll see those. But that's kind of the I/O for the circuit card. Now, lastly, I wanted to talk a little bit about what's in this order, build, and production data. So in this folder, this is going to have all of the stuff you need to know how to order the circuit board. So there are some written instructions to how to go to Rioux PCB, but you don't have to use them. I just use them because they're really cheap. How to order the boards, but all the data you need to get the circuit cards made is in this PCB folder. And there is a bill of materials. Right now I have version A listed out in the zip file. This zip file is what you give to a circuit board. These are called the Gerbers that you use to make the data, or I'm sorry, make the PCBs. It has everything they need. So the first 5 or so that we made, these are the files that we used. And the BOM just has, the production or the actual parts you need to put on the board. The only thing I did want to mention about revision A, there's a couple of minor mistakes in revision A. This ChemBox Rev A modification has instructions of what you have to do once you build up the entire design to get it to work. So the prototype you're going to deliver has these made, but basically there are some forgotten power connections on the schematic, and you have to put a wire jumper between 2 pins of 2 chips, and then between a resistor and a pin. It basically connects power to U62. It's forgotten about on the schematic, but That's the only thing on Rev A you need to do. In Rev B, just integrates this fix in in the circuit board itself. So this fix is only needed on Rev A of the first 5 units that we ever made. So the way you're going to know is if you need Rev A or not, if you need to make the modification, is on the circuit board, or Rev Beta, I should say, Rev Alpha, Rev Beta. This shows Rev B for Beta, but this would say Rev A or Rev Alpha. So actually, let me bring it up here. So on the Rev A, it has this date code 2013-923 Rev Alpha. That's the version you have to apply the fix to. And basically, what happens, one op amp just on the schematic. Actually, the power was never hooked up. So that's a quick overview of the schematic and the hardware, and that should give you enough that maybe ask some questions directly or kind of show you where to go. So in another video, we're going to take a look at the software and how we program the unit.